Welcome back to the conference. Now I am going to open the social networks presentation session. In this session, we have 3 papers. The first one will be presented by Kayoko Yamamoto. After Kayoko, we will have the presentation by Dixon Isafe and Tinoade Adekumbi Ojo. And at the end of the session, for the last 15 minutes, Kasmire and Anran Zhao will present their paper as well. Just to briefly remind you about the rules, so only the speaker should be unmuted and with turned on camera while it's presenting. Attendees can raise the questions, and I would like to encourage them once again to put the questions in Q&A or in the chat box, or even to raise the hand if they want to talk and to discuss with the speaker. Moreover, I would like to remind you that you should respect diversity, and there is a code of conduct at the conference, and everyone who is not behaving in accordance with that code of conduct will be kicked off from the meeting. So the first paper is entitled Utilization of Social Media at the Times of Natural Disasters in Japan, and it is presented by Kayoko Yamamoto. Kayoko Yamamoto received her PhD from Tokyo Institute of Technology in 1999. She joined the Shiga Prefecture Lake Biwa Research Institute in 1998. She became an associate professor at the University of Electrocommunications in 2006 and a professor at the same university in 2019. Her research interests are spatial information science, urban regional planning, environmental science, and disaster science. She has served as a member of the Science Council of Japan and the Senior Science and Technology Policy Fellow at the Cabinet Office. So Kayoko, you have 15 minutes in total for your presentation. Please leave some minutes for the discussion after your presentation. I will stop sharing my screen, then you can start sharing your screen.
Okay.
There should be the green button, maybe on the bottom of your screen, or maybe on the top of your screen. Yes. Okay.
Can you see my slide? Okay.
Yes. It's not yet in the full presentation mode, but yeah, you will start now. Everything perfect. Okay. Thank you.
Thank you, Dragon. Thank you very much for your gracious introduction. Good morning, afternoon, evening, ladies and gentlemen. I'm Dr. Kayoko Yamamoto, a professor for the University of Electrocommunications, Tokyo in Japan. I'm delighted to be here. The theme of my presentation today is utilization of social media at the times of natural disaster in Japan. First of all, I will introduce the background and the purpose of the present study. The cloud computing society has been already developed all over the world, and it is the terms of IoT and IoE when various things are connected to the internet. Under such a circumstance, social media such as Twitter, Facebook, and YouTube are widespreading as familiar information and communication tools in the world. Additionally, geographic information systems, GIS, are actively utilized as powerful data infrastructures at the time of disasters. On the other hand, in recent years, because the occurrence frequency of meteorological disasters such as typhoon, local heavy rains, and heavy snow, in addition to earthquakes and volcanic eruption, tremendously increased. It is the most important issue to adopt the effective measures for disaster prevention and reduction around the world. Additionally, the data infrastructures are toughened in the above measures, and the importance of information and communication technology, ICT, and internet environment is widely recognized, especially in recent Japan. The present study aimed to describe the utilization and issues of social media at the time of the heavy rain disaster in southern Kyushu in 2020. Secondly, I will introduce the utilization of social media and GIS at the times of disasters. The Great East Japan earthquake in 2011 caused immense damage to digital infrastructures and brought area left blank in terms of information communication. immediately after the earthquake and its secondary disasters, including tsunami. Accordingly, various initiatives have been taken to minimize information vacuums. Due to the widespread and immense damage caused by the above disaster, new types of media, such as social media, are actively utilized, and individuals can send detailed information without the limitation of mass media. This is made possible by the spread of various social media. Therefore, individuals can send and receive information in multiple forms by combining images, movies, voice recording, in addition to text. In this way, social media has become part of the disaster information sharing system and has fulfilled an important role in the diversification and layering of information communication methods. In recent Japan, according to the Committee for Policy Planning on Disaster Management final report of the Central Disaster Management Council and the Master Plan for Disaster Prevention, social media and GIS have become an important foundation of all general infrastructures as a data infrastructure, and they are considered to fulfill a vital role in disaster countermeasures. Regarding social media, the Cabinet Secretariat published and distributed the guidebook on the utilization of social networking services, SNS, for disaster response. Local governments are encouraged to utilize SNS at the times of disasters. In fact, a famous example of the utilization of SNS by a local government, Nagano Prefecture conducted information gathering and rescue activities using Twitter at the times of typhoon in October 2019. Nagano Prefecture used their official account for disaster prevention information as a tool to gather rescue request information and encourage users that need to be rescued to submit tweet with images, location information, and the specific hashtags. In July 2020, a flood occurred in southern Kyushu, including Kumamoto, Kagoshima, and Oita Prefecture, and it was caused by torrential rain. The flood washed out many residences and buildings along the rivers, and it affected many people. The central government dispatched approximately 10,000 self-defense force, SDF. Figure 1 shows the location of the above three prefectures and the Kuma River in the southern part of Kumamoto Prefecture. Especially in Kumamoto Prefecture, the Kuma River has overflowed in 13 places. Thus, this river is one of rapid stream of clean water in Japan at normal time. It is a serpentine river.
It seems as we lost Kayoko for the moment.
Wow! Wow!
So we heard you.
This is not sour. Sorry.
Yeah, we heard you very well,
okay,
but I think that the slide was frozen at the moment. So I'm not sure we was seen that river. You talk about some river. So maybe you can just share your screen again and continue, of course.
Maybe this part you mentioned. This figure should, okay?
It's not shared at the moment, your screen. So you should share again the screen because you have been kicked off, it seems, from the Zoom meeting. And maybe you can also turn off your camera to make it better. Yeah. So you can turn off your camera because it seems, yeah.
Yes, I turn off the camera and share my screen again.
Yeah, we can see your screen now. Just
I would like to start this slide. Okay.
Yeah. Perfect.
Okay. Yes. This figure shows the locations of the above Kumamoto, Kagoshima, and Oita Prefecture and the Kuma River in the southern part of Kumamoto Prefecture. Especially in Kumamoto Prefecture, the Kuma River has overflowed in 13 places. Thus, this river is one of rapid stream of clean water in Japan at normal time. It is a serpentine river. As torrential rains and typhoon often flooded the Kuma River and the great damage happened, the countermeasures against such disasters have been undertaken from the past. At present, in Kumamoto Prefecture, the governor, the general public, and scientists discuss whether it is necessary to build a dam over the Kabega River, that is a branch of the Kuma River. Based on the experience and lessons from the past weather-related natural disasters in Japan, at the time of the heavy rain disaster in southern Kyushu in 2020, the Meteorological Agency and the academic societies specialized in climate and natural disaster alerted the general public in southern Kyushu a few days before the torrential rain. Therefore, in this area, most of the residents finished the preparation to evacuate beforehand. However, new issues have come to the front. First of all, due to the influence of COVID-19 epidemic, it is essential to take sanitary measures in vacation shelters. Secondly, in the case of torrential rain, it is necessary for the resident to particularly take evacuation action to public and private buildings and their relatives regions or elevated places. Fourthly, I will introduce our special temporal information system and the function of social media mapping. This figure shows the system design of our system. The system is made up of SNS, WebGIS, mixed reality, MR, and the gallery system, as well as Wikitude, and connecting external social media. Using the function of social media mapping, all of the information with location information submitted from social media, such as Twitter, Flickr, Instagram, YouTube, and web camera, can be gathered and displayed on the 2D data map of WebGIS. When a tremendously heavy rain occurred in southern Kyushu, especially in July 2020, a variety of information related to disaster and its damages using social media was accumulated and displayed on the data map. The data map is included in the function of social media mapping. I will introduce a representative example of submitted information using social media. This figure shows information related to the seriously damaged area in Yashiro City, Kumamoto Prefecture, using YouTube. This area is estuary of the Kuma River. This figure shows information related to the real situation after the disaster in Kuma Village, Kumamoto Prefecture, using Twitter. The torrential rain and flood caused a lot of damage in the basins of the Kuma River, including Yashiro City, that is located in the lower ridges, and Kuma Villages, that is located in the middle ridges. Additionally, this figure shows information related to the serious damaged area in Hita City, Oita Prefecture, using Twitter. Large-scale floods have frequently attacked the basins of Chipugo River, including Hita City, in the past. This river is very large, and the countermeasures against flood have been taken in all of the basins. Fifthly, I will introduce the characteristics of the information submitted using Twitter at the time of the heavy rain disaster in southern Kyushu in 2020, focusing on the information submitting using Twitter. This table shows the counts of hashtags related to the heavy rain disaster in southern Kyushu in 2020. From this table, it is clear that the counts of used hashtags are largely different at and after the time of the heavy rain disaster. Additionally, in terms of characteristics of hashtags, multiple different hashtags indicate that some contents are randomly created. Almost all tweets had hashtags, and many had multiple hashtags. Most tweets contain the hashtags of specific local area affected by the disaster, in addition to the hashtags related to the situation at the time of disaster and call for help. Specific hashtags concerning COVID-19 appeared after the time of heavy rain disaster, and these are related to evacuation destination. Because unlike the past, it is necessary to take sanitary measures against COVID-19 in evacuation shelters. Then let's focus on the use of Twitter at the time of the heavy rain disaster in southern Kyushu in 2020. In Oita Prefecture, some areas are damaged by the torrential rain. At that time, Oita Prefecture government set the staffs in charge of SNS and used their official Twitter account for disaster prevention information as a tool to gather information concerning rescue requests and safety confirmation of the resident. This effort resulted in 10 cases of tweets leading to successful rescues and safety confirmation of the resident. However, Kumamoto Prefecture government just submitted various information using the official email account and website, not using SNS at all. Especially in the southern part of Kumamoto Prefecture, large areas are damaged and precious lives and property are lost in the basins of the Kuma River. Finally, I will conclude my study into 2 points. First point about the utilization of social media. At the time of torrential rain in southern Kyushu in 2020, social media is utilized as powerful tools to submit and gather information related to the disaster by the general public in addition to the central and local governments. Additionally, in fact, Oita Prefecture government set the staff in charge of SNS and used their official Twitter account as a tool to gather the information concerning rescue requests and safety confirmation of the resident. As a result, this effort resulted in 10 cases of tweets leading to successful rescue and safety confirmation of residents. Second point is about the utilization of social media by local government. It was not possible for all of the local governments to effectively utilize social media for many reasons, such as human resources and information literacy of the staffs, as a heavy rain disaster in southern Kyushu in 2020. Therefore, it is important to make use of the information on social media for rescue in real spaces. Based on the real cases used during disasters in Japan, it is desirable that each local government should promote the setting of rules for utilize Twitter in particular, according to the local situation beforehand. It's all. Once again, I want to thank you for the privilege and opportunity to talk to you about this subject. Thank you.
Thank you, Kayoko, very much for a really nice and interesting presentation. Please put your question in the Q&A box if you have any, or just raise your hand. I have one question actually for Kayoko. First of all, it is interesting for me, and it's very nice that social networks can be used also for rescuing some lives, not just for fun and for, I think the social networks are very useful, of course, to making some social connections between the people who are not living in the same city or in the same region. But as we can see from this presentation, it can be used also to be as some utility which can help save some lives and so on. And you noticed, you mentioned in the last points in conclusion that all governments should try to adopt usage of the Twitter for the rescuing. Is it possible to adopt your solution, meaning how it's pluggable, applicable for different regions? Can we, for instance, in Serbia, in my country, just take your approach and just replace, Japanese terms with my language terms, and then somehow use the same approach for some situations here in my country? Is it possible, and how complicated it is?
Very difficult. Language hazard you mentioned. And in the case of Japan, central government encourage local government to use Twitter in particular to gather information and information concerning rescue requests and confirmation of resident. However, language hazard is very different. Is very difficult. In the case of Japan, many foreigners are living in Japan, and we have to information in many languages. However, we have limitation to get to provide important information to every foreigners. And if you would like to apply our method, Japanese method, to your country, I will send the guideline published by the central government. Yes, I will send you, and please translate.
Yes, thank you very much.
Yes.
And there is one more message in the chat, which is talking also about the same point, that the social media are important. So the importance of social media can't be overemphasized. Many have been rescued in Nigeria with a call for the help on Twitter. So it is also useful in Nigeria as well. So I'm very happy also because of that. So thank you very much, Kayoko, for your presentation. We have to go further with our program. And now I'm going to introduce the next speaker. Unfortunately, there is also the similar problem with connectivity issues for Dixon, because I noticed Dixon this morning, he was in the call, but at the moment he's not at the call. Because of that, I will go further and play a video of Julia and Anran of our next presentations. After that, Anran is in the call. I suppose she can provide the answers on some of your questions. But Anran, I'm going to play the video as we discussed before. Just briefly to introduce the Julia and Anran. So Julia Kasmire is the first author of this paper. She's a research fellow with the Kathy Marsh Institute at the University of Manchester and the UK Data Service, working on the application of computational and empirical methods within social science research. And the second author of the paper is Anran Zhao. She's also based in the University of Manchester. And Anran works as a research associate in the computational social science team for the UK Data Service. She develops and delivers training events, including workshops and webinars and online trainings materials to meet the needs of social science and cross-disciplinary researchers. She holds the degrees in art history, English and business communication and data science. So she's also coming from different backgrounds, and she's really competent for this, let's say, the multidisciplinary conference, ICT and Hedge, Social Science and Humanities. So Anna, now I'm going to play your video. Oh, Julia is also with us. That's really great. And after playing your video, you will have maybe some questions from the audience and opportunity to discuss with them some aspects.
Okay, great.
Okay, just give me the moment.
My name is Dr. Julia Kasmire, and I work in the Computational Social Science Training Team with the Kathy Marsh Institute at the University of Manchester and with the UK Data Service.
Thanks, Julia. Hi, my name is Anran, and I work as a research associate at the Kathy Marsh Institute at the University of Manchester. I work in the Computational Social Science team in the UK Data Service.
Today, we are presenting a recent paper about discovering the arrow of time in machine learning. I'll start by saying that machine learning is good for getting computers to do all the boring, repetitive, or difficult tasks for you. This includes tasks like automatic classification, clustering, decision-making, anomaly detection, prediction, and lots more. One you might be familiar with is the algorithm that suggests new films to watch when you've finished watching something on a streaming service. I can assure you that no human is working away somewhere to personally curate those suggestions for you. Machine learning is almost essential when the data are too big, too mind-bendingly complex, too inconsistent, or expanding too rapidly for non-computational methods to work with. Now, machine learning algorithms or models vary in several ways. For example, they could be supervised, unsupervised, or semi-supervised, as some machine learning models deal with data that is ordered, often in chronological order. A popular example being time series prediction. At the same time, many machine learning models do not take any account of time or order in their data, at least not explicitly. So there are lots of options to consider when choosing a machine learning algorithm, mostly based on the properties of the data you want to analyze and the task that you want to use the machine learning algorithm for. Some things to consider include, but are not limited to, the supervision needed, the tolerance for errors or data asymmetry, its ability to count for temporal or ordered features, but there's many more options. Something I want to make very clear is that algorithms that explicitly address time, like the time series prediction algorithm I mentioned earlier, are not very tolerant of data that is full of errors or asymmetry, as when the data are not well distributed in time. On the other hand, non-temporal algorithms are much better at handling errors and asymmetry. This makes machine learning very appealing for the kind of messy, high-volume, rapidly growing data that's so interesting to so many social science and humanities researchers. This includes things like videos and images, social media posts, chats and forum discussions, real-time location data, much more. Clearly, researchers have to carefully consider their options when selecting a machine learning method to use. But, most of the interesting data that we might want to use machine learning to help us analyze is both error-filled and temporal. For example, social media data. It's very messy and complex because it has language, images, video, emoji, hashtag, links, all kinds of things. It's growing rapidly in volume and complexity, and it's created at specific points in time and responds to specific temporal contexts. Another example, medical diagnoses. They're highly dependent on rapidly changing medical best practice and technology, and medical diagnoses are wrong about 30% of the time, but you don't know that until potentially much later. Essentially, the arrow of time is still present, at least in some way, in the messy data that we might want to feed to non-temporal machine learning models. When we noticed this, we got a bit curious. We wondered, can this implicit arrow of time influence machine learning performance? We thought, let's find out. So we created a proof of concept experiment to explore it. We got some social media data that we were confident captured an implicit arrow of time. Twitter, over a few years, using the keywords vaccine and UK. This should cover both long-term discussions and recent events. Then we trained 2 different machine learning models to automatically classify those tweets according to the time they were created. We picked naive Bayes classifiers and recurrent neural networks, and we asked them to classify the tweets by time period of origin. Importantly, even though the task is about classifying into time, it is using time periods as simple buckets to sort the tweets into, not actually using time in any meaningful way. We thought about classifying them by sentiment, but we didn't want to manually classify all the tweets in our dataset. Obviously, this is an example of why machine learning is helpful for tasks that are too tedious for people. So let's start off by looking at some word clouds for the different time periods we covered. Unsurprisingly, the 2 most recent time periods are big on words like COVID, COVID-19, trial, things like that. Going further back, we see less obviously specific words dominating, things like virus, risk, age, case, free, and there's many more of these present in several different time periods to different degrees. In 2018.4, we see MMR, HPV, and girl. I did a bit of research and found that 2018 set recent records for high rates of measles, mumps and rubella infections. 2018 was also the year that UK introduced HPV vaccine for boys as well as girls. So clearly these words clouds are showing us that even outside of a global pandemic, some time periods display time-sensitive contexts. Now, just classifying our data won't really address the research question, so we divided the data into 3 subsets, one with only the most recent time periods, one with most of the time periods, one with all of the time periods. And then we train and test both of the different machine learning models on all of the data sets, starting from 0 each time, measuring performance. Performance in this case is simple accuracy. There's no focus on false positives or false negatives. We expect that if the machine learning models are not time sensitive, accuracy for dataset 3 should be as good or better than datasets 2 and 1. However, if the models are time sensitive, accuracy for dataset 3 should not be as good as for datasets 2 and 1. And now I'll pass it over to my colleague Anran for the technical stuff.
Thanks, Julia. Alright, next I will introduce how we carried out our project, including data collection, preprocessing, and modeling. And then I will talk about the results we got. Also, as Julia and I are trying to push reproducibility as much as possible for this project, all the code and relevant datasets are available on UK Data Service account on GitHub. You can see more in reference 6. So if you want to reproduce or play around this project on your own, feel free to go there and have a try. Alright, let's start with data collection. The project aims to explore how the performance of machine learning models on classification tasks varies when handling Twitter data covering different time frames. To do this, we decided to collect the tweets on our own. Fortunately, Twitter offers an API so that we can collect the tweets with access keys to Twitter archive rather than scraping manually from the website. And here we use Tweepy package to facilitate this process. Eventually, we collected 9 datasets from April 2017 to April 2021 with 6 month intervals. Each batch contains 1,200 tweets, and the selecting condition is that the query is vaccine UK, which means that the tweet must contain vaccine and UK, no matter that the 2 words are together or separate. With raw data at hand, we then come to data preprocessing part. There are various tasks in this part, and here I listed some of the most important ones to produce the clean data for the 2 models. We started with transforming Tweepy results to table-style presentations, and then we sliced the data to keep only the tweet text and the time of creation, and then re-encoded the time of creation so that it's down to month rather than second. And then, as this is essentially a text classification project, we also need to do some necessary natural language processing work. We remove the mentions, URLs, emojis, etc., which are very common in tweets but not helpful for modeling. We also remove the punctuations and stop words. Last but not least, with NLTK package, we applied part of speech and then lemmatization to each word so that they are transformed to simple lemma version according to context. For example, further to far, boxes to box, recording to record if it's a verb, and to recording if it's a noun. With the cleaned data, we then come to the modeling part. The naive Bayes classifier, or NBC, is relatively straightforward. Lemmatized tweets are converted to text blobs with the text blob package. Text blob is a very useful package built on the shoulder of NLTK. Following these, 3 empty NBC models are trained, each on the training portions of dataset 1, 2, and 3. The trained NBC models are then tested on the corresponding test portions of the same datasets. On the other hand, the recurrent neural network, or RNN, is relatively more complicated. The RNN model here contains 5 layers. The first layer converts a batch of string inputs to a token index sequence. The second layer then transforms it to vectors through word embedding, which means that after sufficient training, different word sequences with similar semantic meanings will have similar vector sequences. The third layer is a bidirectional wrapper, which propagates the input forward and backward through the RNN with long short-term memory or LSTM architecture. And then the fourth one is a ReLU activation layer with 64 nodes, and the fifth is the output layer with softmax activation, where the number of nodes depends on the number of classes. So here's our result. Both the NBC and RNN models demonstrated good performance on predicting the time class of the tweets. The least accurate performance in any experimental condition was just below 80%. The most accurate NBC performance of over 90% comes from dataset 1, which was the smallest subset that had only the 3 most recent time periods. The NBC accuracy falls as more data is added, with dataset 2 showing 84% accuracy and dataset 3 falling just below 80% accuracy. The RNN model shows a similar pattern, although the drop in accuracy is less pronounced, from 89% to 81%. It to some extent indicates that RNN models seem to exhibit higher sensitivity to time and thus better capture the patterns in the more complex cases with more data over longer time frames. Overall, the results contradict the commonly accepted idea that machine learning is always improved by more data, and instead it supports the idea that even very simple and decidedly non-temporal models, such as an naive Bayes classifier, can be disrupted. Here's a graph that tracks the change of accuracy and loss for the train set and validation set in the RNN model. We can see how the model learns through training as passing the data through multiple times. The gradual improvement in accuracy and the gradual decrease in loss on the training data, which are the blue lines, are close to the accuracy and loss for the validation data, namely the orange lines, showing that the model didn't suffer much from overall underfitting. It also reveals that handling data of higher temporal complexity needs more iterations. As for dataset 1, 10 epochs are enough to find the optimized weights, but dataset 3 requires at least 20 epochs. All right, now let's give the mic back to Julie.
Thanks, Anran. To reiterate, both models can do the classification task, but the accuracy drops as the dataset size and presumably complexity grows. This is especially apparent with the NBC. The real consequence is that we want modelers to consider time when selecting an appropriate machine learning algorithm. This accounts for both how time is handled within the data, whether it's implicit or explicitly present and in what context, and how the machine learning model accounts for time, even if it's in an implicit or disrupted way. Moving on toward the end matter, here are our references. There are obviously quite a few more in the full-length paper that we have submitted to the conference. Particularly want to draw your attention to reference number 6, which is our GitHub repo, where you can test out our code and have a look at our data. We are both contactable via email or Twitter if you have further questions or if you want to discuss these topics with us. The capriciousness of the internet being what it is, we hope that one or both of us are present in this Zoom session as well, at least on the chat, if not actually connecting via voice and video. Thank you very much again.
Thank you also from my side to the Anran and Julia. I noticed that Julia connection is quite unstable. But anyway, if you have any questions, it's time now for the question, and I believe that Julia and Anran are ready to respond to your questions. I would like just to say that this is one nice proof of the open science paradigm, meaning that you offer your data, your source code, that we can, repeat your research, that we verify that the results are as you claim it is, and that we can also play further with those data and your open source, meaning to use your data and your software and produce some new research on top of those data with some small modification of your source code. So it's really great, and I believe that the other researchers should go also in that direction. Just to check, there is one message in the chat that was interesting. Thanks. Yeah, and I think I received one email with the interest of your presentations. because that researcher wasn't available to be today with us because some other meetings already allocated. And so I responded, of course, that all recordings will be available after the meeting, and probably or possibly that researcher can contact you with some further questions or possible collaborations. So do we have any question now for Julia or Anran related to their research? My basic question here is actually whether it's this is one completed research or you have some further plan in which direction you would like to go now, or it's completed and now you're going to some other completely new tasks and new research projects.
Yeah, Julia might not be able to turn on her audio. Yeah, but she said in the chat that absolutely open for further
Yeah,
research.
that's great.
Yeah, actually, in our paper, we discussed some like further like actions we could do regarding this project. For example, we can give like more geographical conditions to like kind of smaller, make the data sets more accurate, or like give it more tasks. And also we were thinking about the curriculum learning, which is also like kind of a topic in this field that's relevant to RNN model. That is kind of like giving the RNN model first from easy tasks and then to like harder tasks, so that the model can learn gradually. And I think that's kind of relevant to this topic, because it's still like yeah, it's about like how we order the data set, the training data, and how that affects the performance of the model. Yeah, so that's also a very potential topic we want to explore in future if possible.
Yeah, thank you very much. So that again emphasize some fears for